Welcome to breakout sessions for Weeds, Pest, Pathogens track. Before I introduce today's speaker, I'd like to mention that we will be having one CEU in Integrated Pest Management available for attending this breakout session. We will have details at the end of the session offering a CEU on how you can access your credit. We appreciate the opportunity to partner with CCAs to offer these additional benefits. I'm happy to introduce today Dr. Nick Seiter presenting Integrative Insect Management, What Did We Learn in 2020? Dr. Seiter is a field crop entomologist at the University of Illinois. His research and extension program is focused on developing integrated pest management recommendations for soybean and corn farmers in Illinois. He has his Ph.D. in entomology from Clemson University and Bachelor's of Science and Master's of Science degrees in entomology from Purdue University. You're free to go, Nick.
All right. Thank you, Todd. Thank you all for having me here today. So in this presentation, I'll be talking about really two of the insect pests that we maybe paid the most attention to in 2020 in soybean. Not necessarily the most impactful every year, but two that we did see an impact from this past year, and that's the Dectes stem borer and the bean leaf beetle. Now, bean leaf beetle has been with us for many years, probably as long as we've been growing soybean in Illinois, probably before that in green beans and other legumes. Dectes stem borer is an insect that we've been paying a little bit more attention to in southern Illinois in recent years, and not one that we've thought of historically as a major pest in Illinois, but one that we're seeing more and more, and one that we'd like everybody to learn a little bit in terms of the biology, in terms of the management of that particular pest, to be ready to deal with it in soybean in southern Illinois in particular. So with the Dectes stem borer, this is a Longhorn Beetle, bit of an unusual pest for us. It's going to be the only insect in this family that we really deal with in agronomic crops in Illinois. Typically, we think of this family as a pest in forests. There's a variety of Longhorn Beetles that are pests of maple trees and oak trees and so on. So with the Dectes stem borer, you have the adult is this bluish gray beetle, lawn antennae, that's where it gets the name Longhorn Beetle. And the adult isn't really going to damage soybean. We're not really going to see damage from the adult itself. However, the larva is going to actually feed on the pith within that soybean stem. And as you can see here, this damage can be at least pretty showy, fairly noticeable if you go in and cut one of those stems off and open one of those stems up and find this feeding. Now, in terms of the life cycle for Dectes stem borer, those adults are going to become active in June and on into early July. They're actually active over a relatively long period. The female can be laying eggs for as long as 6 to 8 weeks. And this is going to complicate our management a little bit when we talk about if we were trying to prevent that egg lay. So she's going to lay her eggs, the female, within the petiole, and that egg's going to hatch, and that larva is going to tunnel right into that petiole where the egg was laid, and that's where it's going to do its feeding for the first part of its life cycle. And as that larva feeds within that petiole, feeds on the pith within that petiole, it actually will shut down vascular flow within that petiole, and ultimately you'll see a petiole that wilts and dies. And when we look at the signs or the symptoms of infestation with Dectes stem borer, that's very often the first one that's going to be available to us. That's the first thing we're going to see. And where this occurs in the canopy, it's really going to depend on how developed that plant is when they arrive. So you can find these in the very lower canopy. You can find these in the upper canopy up at the top of the plant. It just depends on where that plant happened to be at when this adult female arrived. As this develops, you'll actually see those petioles will eventually fall off of that plant. And so you'll see what we call flagging petioles, where the petioles hanging off of the plant, or ultimately it falls off and you can just see the little stump where that petiole used to be attached to the main stem. Now, this damage, it can be a sign that the insect is there. We're not going to see, for instance, defoliation from this that would amount to anything. The number of petioles that are going to be removed by this sort of feeding is inconsequential in terms of yield of the plant. But we can use these as our cue that, hey, we've got some Dectes stem borer within this field when we start to see a lot of these flagging petioles. Now, from the petiole, the larva is going to tunnel into the main stem, and that's where at least the showiest damage from this insect is going to occur. So they're going to feed on the pith, and especially they're going to feed on sort of the structural part of that pith within the xylem and the phloem. And so the actual impact on vascular flow within the main stem is relatively minor, but they are feeding on that material in there. They'll line those tunnels with frass or excrement, as you can plainly see up here. So it's not just going to be a hollowing out of that stem, as you'll see sometimes for a variety of reasons, but they'll actually have this tunnel going through there that's going to be lined with their excrement. Now, if you look at this damage, it looks pretty bad, and especially the first time that you see this, I think most people would say, that looks pretty bad. That looks like it's going to have a pretty serious impact on yield. It actually doesn't. So the actual yield reduction that we see from the tunneling in and of itself, from this feeding on the pith in here, is minimal, if any. We've determined this. My colleagues down in the southern U.S. have been able to look at fields where you have maybe 80% of plants tunneled, maybe 100% of plants tunneled. They can actually artificially exclude that tunneling with an insecticide seed treatment that we don't have labeled in soybean. It's not one that we used. It's one that includes a material called fipronil that we don't really use in agronomic crops. We use it to control fleas in dogs and cats. It's a systemic material, actually travels throughout the soybean plant. And with that material, we can actually experimentally exclude Dectes stem borer from these plants, something that we can't do very well with the conventional insecticides that we have available to us. When my colleagues in the southern United States did that, they noted, surprisingly, they didn't see any damage, or they didn't see any difference in yield between these infested plants and between non-infested plants. So just due to the lack of serious interference with vascular flow, perhaps due to when this damage occurs, it's getting worse and worse as the season goes on, and a lot of this serious tunneling you don't see until the very end of the season. But regardless of the exact reason, we don't see yield loss, not measurable yield loss, from this stem tunneling in and of itself. And that's good news. If we did see that yield loss, this would be a much more serious pest than it currently is. What we do see, what we can see at least from Dectes stem borer feeding is lodging. Now, the way that this occurs, as that larva matures, and once the fall arrives, and once that plant starts to mature, once it starts to desiccate, that larva actually works its way down to the base of the stem, and that's where it's going to overwinter. It's going to spend the winter as a partially grown larva down in the base of that stem. To do that, and to do that effectively, it's actually going to girdle that stem from the inside out. Now, these larvae are partially cannibalistic. They'll feed on each other if there's more than one larva in that plant. And so that's probably a mechanism to protect itself. So when it's time to overwinter, larva is going to work its way down. You can kind of see here how that stem has been chewed in sort of a semicircle there around the base of that stem. And that's where it's going to spend the winter. You'll note that it lines that tunnel with sawdust and with frass. When she does this, it weakens the stem and the stem can fall over. And that's where we can actually see some yield loss from this insect, is when we see lodging prior to harvest because these overwintering larvae have girdled the inside of that stem. We don't see this every time that a field is infested. In fact, we don't see it all that often. Where we're more likely to see this lodging is when, for whatever reason, typically the weather, those plants have had an opportunity to sit out there in the field for some time after they've matured. So it does take some time for this to occur. Where we saw some lodging spots, especially was in, if you recall, the fall of 2018, had fairly wet conditions throughout that fall, had a difficult time getting into the field. And of course, as you all remember, that carried over into the spring of 2019, where we had a hard time getting into the field to plant. During that fall of 2018, in some areas, we did see some lodging from this insect. And of course, that can have a serious impact on yield, and not just on yield, but on harvest efficiency where that occurs. So that's something we want to avoid, if at all possible, is that potential for lodging. Now, in terms of management, unfortunately, like a lot of what we call protected feeders, where this larva is feeding inside of that soybean plant or inside of another plant, we really have a hard time getting any kind of control with an insecticide. And in fact, we've never been able to demonstrate economic control with an insecticide. You can control the adults easily enough. Recall that those adults have a very long period over which they're active, 6 to 8 weeks, where they're out laying eggs. And so what happens if you control those adults, you'll find that one application to control the adults would not be sufficient. You would need multiple applications, 2 or possibly even more applications to knock those adults down. My colleagues out at Kansas State have been able to do this. They've been able to control adults and get a reduction in stem tunneling because of it. However, to accomplish this, they need to start early and they need to spray repeatedly, multiple applications. We just can't see that working out economically, especially when you consider the relatively low risk of actually having tunneling from this, or actually having tunneling, actually having girdling at the end of the season following that tunneling. Recall the tunneling itself isn't really going to impact yield. So we're not recommending an insecticide for that reason. Of course, once that larva is in there, it's in there. There's nothing you're going to spray that's going to reach that larva and control it after that infestation's already occurred. What we can do is manage that lodging and try to, promote cultural practices that are going to get us out of the field earlier, and that are going to prevent the impact of that lodging. Biggest and most important practice that we can encourage here is to prioritize a timely harvest. So we want to make sure we get these fields get these beans out of the field as soon as we can when we have that Dectes stem borer infestation. Obviously, we don't always have control over that, right? Obviously, weather dictates a lot of that, but what we do need to be able to do during the season is identify fields that have Dectes, that have a lot of this stem tunneling in there, and just kind of keep an eye on those fields and keep those in mind at the end of the season when it's time to harvest, and maybe put those first on our docket when it's time to get them out of the field so that we don't see this lodging. Now, in addition, again, to going out and opening those stems up and finding the larvae, we have a couple of mechanisms that we can use to identify those infested fields. One, of course, is these petioles that I've already mentioned that will start flagging off of there when the larva is moving through that petiole. The other sign that you're going to get that's more of a little more of an urgent warning sign at the end of the year is when you start to see these little piles of sawdust at the base of the stem. And I believe you can kind of see here where that larva has girdled the inside of that stem, but when they do that very often, it will push some of that sawdust to the outside of the stem, and you start to see these little piles of sawdust at the base of those plants. And that's a real indication when you see that we might need to get out of the field. Might need to go ahead and get those plants out of there before we start to see lodging from this damage. And it's important to remember, again, it's that lodging that we need to prioritize. If you're not seeing lodging, you're not losing yield from Dectes stem borer, from the tunneling in and of itself. One thing we saw a lot, so I used to work in Arkansas where we had actually much higher levels of Dectes stem borer infestation. We'd see as many as, 80 to 90% of our plants infested without seeing yield loss. What we would see in those situations, we might have a field where we had a pocket of nematodes, root knot nematode down there, for instance, impacting soybean. And we'd go out and look in that patch of nematodes and split it open, and sure enough, there'd be a stem borer in there. Well, as we went out and looked in the rest of the field, the non-affected patches also had Dectes stem borer in there, but they weren't the ones getting split open. So it can kind of take the rap for some other damage in some cases, some diseases, some nematodes and that kind of thing. But just keep that in the back of your mind that the actual stem tunneling from this insect is not the issue. It's the lodging that we occasionally see that can cause yield loss and economic losses from Dectes stem borer infestation. In terms of some of the work we've been doing in Illinois, one of the things we're looking at is the impact of seeding rate, and based on seeding rate, the impact of the radius of that stem, the size of that stem, on this larva's ability to work its way down there and girdle those plants. We have some anecdotes, of course, that having a higher seeding rate and reducing the size of that stem may help to prevent this. We want to verify whether or not that's true. We're working through this data at that point and hoping to get some answers on that. It doesn't appear there's a dramatic effect on it, but that's often how these cultural practices go. What you do see here that's kind of interesting, we had 2 locations in 2019 and 2020. It had a fairly wide range of adult populations here, in some cases very low levels of adults up here. 2.5 per 25 sweeps is quite high for Dectes stem borer in a field, and you see that resulted in 58% of those stalks having tunneling. However, when we go down and look at the actual number of live larvae that we found evaluating these fields, that was not the highest field that we saw. And what was interesting in this particular field, we saw a high degree of parasitism. So we went in and looked at these live larvae. In many cases, instead of a live Dectes stem borer larva, we would find several larvae like this, which were a parasitoid, a wasp or a fly that's actually feeding on those larvae and attacking them. And we saw more of this in fields where we had higher adult populations and a higher percentage of those stems that were infested. So that's something interesting that we'd like to take a look at, as well as what are the effects of these natural enemies, these parasitoids, on that Dectes stem borer population. Finally, one thing I should point out that I forgot to mention earlier, where we see Dectes stem borer most often is in the parts of the state, particularly southern Illinois, where we're doing a lot of no-till, a lot of conservation till. And there's a reason for that. On a regional level, having reduced tillage does promote survival of those larvae over the winter. When you destroy that stubble, it does reduce the survival. However, what you'll find in an individual field, if you go out and try to control that population by tilling, you're going to have fairly mediocre success with doing that. You're not likely to see a result in one field from that practice. You'll reduce survival, but we're not talking about like 80, 90, 95% control. We're talking about reducing survival of those larvae in that field by maybe 40% or so, something like that. That's what's been published in the past. So keep that in mind. If you're in a heavy no-till region, you're more likely to see these insects. And I'd be curious to see what we have up in northwestern Illinois, for instance, where we have some reduced tillage up there. This insect is fully capable of surviving the winter on into northern Illinois, but it hasn't been an issue for us outside the southern third or so of the state. Now, what I want to point out there, if you're in a no-till system and you've had issues with Dectes stem borer, I don't necessarily encourage you to go in and start tilling that field, right? On an individual field basis, you're not likely to see much of an effect from that. And frankly, the damage that we see from Dectes stem borer is going to pale in comparison to erosion losses and all the other factors, all the reason that we're using no-till in the first place. So what I would encourage you to do is to continue your tillage practices or your no-till practices as you're doing, but just understand if you're in a no-till region, you're more likely to see this insect than if you're up here in East Central Illinois, where just about every field is being tilled. But that's the deal with Dectes stem borer, and the big thing you want to be careful of with that, manage the lodging. If you're just seeing the tunneling and you're not seeing lodging from that, it looks ugly, but it's not going to hurt you in the long run, as long as we can prevent that lodging and not see that at the end of the season. So with that, I'll go into the insect that probably we had the most trouble with in soybean this past year, and that's the bean leaf beetle. Now again, bean leaf beetle is an insect that we're used to seeing in Illinois. Very common. You could argue it's probably the most common soybean pest we have in Illinois, and you would be hard pressed to go out there and scout a soybean field throughout a season and not find at least a few of these guys. You'd be hard pressed to grow a patch of green beans in Illinois and not find at least a few of these guys. Extremely common insect. However, it's an occasional pest because it's somewhat rare for us to see the kinds of numbers on bean leaf beetle that it takes to actually cause significant yield loss. We actually saw that in a few cases this last year, especially in central and northern and northeastern Illinois. We did have some instances where we suffered some yield loss from bean leaf beetle, sort of an unusual outbreak of this insect. Now, in terms of the biology on bean leaf beetle, it's in the same family as the corn rootworm beetle. You'll note that it looks very similar to an adult western or northern or even southern corn rootworm. And there's some similarities there in terms of its behavior and in terms of its life cycle. There's some key differences as well. Of course, one key difference is it's the adults that we're worried about as a pest in this case, as opposed to the larvae. I'll talk about the larvae a bit. We also, with the bean leaf beetle, we have 2 generations per year, and it's actually the adults that are going to overwinter. So you can find these right now. I mean, if you wanted to go burrowing through the snow, you could go out and find adult bean leaf beetles. You'd have to dig around in some leaf litter on the edges of fields and on tree lines and that kind of thing. They're kind of difficult to find, but you can find them out there. Incidentally, this is one of those few insects that when we talk about the effect of the winter on overwintering survival, we can actually get some measurable impact on overwintering survival of bean leaf beetle based on the type of winter that we have. In fact, my colleagues at Iowa State have developed a model where you can predict sort of the overwintering survival based on the weather conditions that you've had in a given year. Now, where that's really going to have an impact would be on the first generation of these beetles, or I should say the overwintered adults that come out first thing in the spring that you see on soybean seedlings very early on. That's where you can see an impact if we have a heavy winter. But we're going to have 2 generations per year, so those overwintered adults are going to come out typically before soybeans are planted, honestly. They'll come out as soon as we start hitting some 55, 60 degree days, a string of those on in the spring. They'll be feeding on maybe alfalfa, maybe clover, maybe other legumes that are out there, but they do tend to concentrate in soybean fields when those soybeans first start to emerge. And then you'll have another flush of adults in July. That one's usually kind of spread out. We usually don't see a lot of impact from that generation, but they'll develop and you'll get a final flush of adults in the fall. And that's typically, if we're going to see an impact from bean leaf beetle, that's typically where we'll see it. And one thing in terms of identification here, just real quick, you'll note that the color and the pattern on this insect varies quite a bit. One thing you'll always have here is going to be this little black triangle that sits right behind this shield that we call the pronotum up here in the head. So you've got the head, the pronotum, and then this little black triangle that's pointing backwards. You're always going to see that on a bean leaf beetle adult, and that's going to distinguish it from adult corn rootworms, southern corn rootworm in particular that also has these spots. That's going to distinguish it from lady beetles. So don't worry about whether or not you have these spots, what the exact color is. You'll even see some of these that are more of a brick red than the color we're seeing here. Look for that black triangle in terms of identifying it. So I mentioned that this is in the same family as the western corn rootworm, the northern corn rootworm, the southern corn rootworm. The larvae actually look very similar to corn rootworm larvae, if you can find a bean leaf beetle larva. And they're going to be feeding primarily on the roots and the nodules of soybean plants and other legumes. So you can go out and find these if you look hard enough during the production season. Unlike the corn rootworm, we don't really see pruning from these, okay? We don't see large amounts of root tissue removed by the feeding of these larvae. Perhaps they're more spread out. Perhaps they just don't do as much feeding per larva. Perhaps those soybean roots are a little better at compensating for that damage. But regardless, we don't see root pruning and we don't see yield reduction from the feeding of these larvae. So the larvae with bean leaf beetles tend to be a little bit more of a curiosity than anything else. And it would be great to understand a little bit more about the factors in the soil that promote survival of these larvae, more so that we can better predict outbreaks like we saw last year over a fairly wide area in Illinois than necessarily dealing with the larvae themselves. We don't really worry about bean leaf beetle larvae. But these are going to be present in the soil, out in soybean fields. So after those first adults emerge in the spring and they're out there laying eggs, especially in late April, early May, in some of those soybean seedlings, those larvae are going to be feeding on the roots until the adults again emerge, again really beginning in early July is often when we're going to see those adults, those first generation adults. And then of course that generation will lay eggs in soybean again. You'll see larvae again in soybean in July on into August, but the larvae themselves aren't causing problems in terms of yield reduction. So we can see yield reduction from bean leaf beetles in 3 different ways, all caused by the adults, and I'll sort of discuss these perhaps in rank of importance. So the damage that we most closely associate with bean leaf beetles that we're the most familiar with on a year-to-year basis is defoliation. So the adults do feed on soybean foliage. They'll actually skeletonize that foliage in some cases. The damage is somewhat similar to Japanese beetle damage in that regard. They like to feed in between those soybean leaf veins. And what's interesting about bean leaf beetle, kind of tends to be the first pest we see in soybeans in a given year. And again, it tends to be the last pest that we see. And it's actually the same generation that we're seeing in both cases. So we'll see that flush at the end of the season of adults that especially likes to concentrate itself in the latest maturing beans that we have. Those act as kind of a magnet for those beetles, which are fairly mobile, and they tend to concentrate in those last green soybean fields. Then they're going to overwinter, and in the spring, when those beans first emerge, those first bean fields that emerge also tend to concentrate these. And we'll see in seedling beans in particular, we can kind of get caught off guard by these in some cases, and it can look fairly bad in some cases because it's very easy to see this damage on seedling beans. And last year we actually saw in some cases some fairly significant defoliation. This is a part of the field here up just maybe about 45 minutes north of me here in Champaign. This is actually about the worst bean leaf beetle defoliation I've ever seen, and this actually exceeded just barely our economic threshold in post-bloom soybean. Now, it occurred late. It occurred after most of the seed fill was already complete. We probably saw very little actual yield loss in this field because of when that occurred. But when we talk about soybean defoliation, it being rare that it causes yield losses, it is rare. That doesn't necessarily mean it never happens. It can happen in some cases. But what we do want to remember about defoliation, it takes a lot of that kind of damage to really see a reduction in yield. How much is a lot? Well, we're talking about an economic threshold of 30% defoliation before bloom. I've never seen that. I've been an entomologist down in Arkansas where we see a lot of insect pressure. Been an entomologist up in the Midwest, both here over in Illinois. I've never seen with my own eyes 30% defoliation before bloom. Doesn't mean it doesn't happen. But it doesn't happen terribly often. Soybeans are pretty incredible at overcoming defoliation prior to bloom. Where these thresholds come from in many cases is actually from the models that we developed for hail assessments, for assessing damage potential in hail. So if you think about plants being able to lose pretty large proportions of their effective leaf material through hail damage before bloom, well, they can suffer a lot of insect damage before bloom as well, before you start to see yield reduction. We reduce that to 20% after bloom. That's still quite a bit. This that you're looking at down here is a little bit over 20%. That's probably right around 25% there. It's a lot. It's going to look pretty bad when you're sitting at 20% defoliation, so keep that in mind. And just an example of where you should start to get concerned about that, start to think, maybe we're getting pretty close to an economic threshold here. This is a picture I took a few years ago, and I actually went in and measured the percent defoliation in this field, and I came up with 16% defoliation when it looked like that. So again, it happens. It's something that we need to be vigilant for, but often what we think is a damaging level of defoliation, we're probably actually looking at maybe 5 to 10% defoliation that's going to be more cosmetic than having an impact on yield. But we do have some other mechanisms where bean leaf beetles can reduce yield. One of maybe the low-key mechanisms is its potential to transmit bean pod mottle virus. You can see here the symptoms in terms of what this does to the leaf. Of course, the big concern with bean pod mottle virus is reducing seed fill and then reducing quality of those seeds by discoloring the seeds. We can see in some cases transmission of bean pod mottle virus by bean leaf beetle. Now, this can be a little bit difficult to predict, but you do tend to have a field history component to this, although in some cases it can be transmitted through the seeds. It can be transmitted through insect feeding. There's a variety of ways this can be transmitted. Tends to be more of a problem in the southern United States than it is here in Illinois. But if you have a field history, if you have a history of issues with bean pod mottle virus, then you probably want to be a little bit more aggressive on bean leaf beetle control than what we're talking about here. Again, far from something that's going to happen in every field every year. In fact, it's going to happen in a relatively small minority of Illinois fields. But if you find that you have an area where you've got a history of this issue, then you might consider managing bean leaf beetle just a little bit more aggressively than if you don't have this problem. Now, the real issue with bean leaf beetle, or the real issue, probably the most significant issue in Illinois, and an issue that we saw a fair amount of last year, is with pod scarring. So what this bean leaf beetle does as those pods start to mature, and especially when you have the leaves starting to yellow a little bit and starting to become a little less palatable to those beetles, but the pods are still green, then they'll switch over and they'll start feeding on the outside of these pods. When they do this feeding here, what happens initially is not a whole lot. They're targeting the pod. They're not actually targeting the seed itself. But when they remove that tissue from outside the pod, and especially when that tissue removal gets close to the margins of the pod, as you can see here, well, then as that pod starts to dry down, that pod is going to kind of tear away from that, and you're going to get these gaps, as you see here. You'll get these little openings in the pod, and that becomes an entry point for moisture. It becomes an entry point for pathogens that are going to lead to seed rots and other quality reducing pathogens within those pods. And so you can get a reduction, especially in quality from this, that you can ultimately get docked for at the elevator. You can also see some yield loss, especially if this occurs early enough to where those seed rots actually lead to a reduction in seed mass. So this is really what we want to target when we talk about bean leaf beetle feeding. It's not the defoliation so much as it is their potential to scar pods. Again, this isn't always going to happen. This is going to happen primarily in those fields where the bean leaf beetle population is out there and those leaves start to senesce, but the pods are still green. So that's where you really want to look out for it. And we want to base our management decision, because of that, not just on bean leaf beetle populations, but on how much scarring you can actually find out there. And where we want to target this, we want to target these beetles while the pods are still green, and while we're seeing around 8 to 10% of pods scarred. That's going to be the economic threshold. When we start to see that, that's where we want to put out an insecticide to control these bean leaf beetle populations. When I say 8 to 10%, you want to lean more on that 8%, or maybe even a little lower than that if this is occurring early. So if you have pods that have a lot of maturing left to go and you're seeing a lot of bean leaf beetle numbers out there, you want to be a little bit more aggressive. Whereas the closer you get to seeing those pods yellow, the more of that kind of damage you can tolerate. And once you have the majority of the pods yellow or even brown, then you can stop worrying about this. Recall, it's the scarring that occurs at these earlier stages that then leads to those holes as the pods mature. So this is more of an issue when you're still sitting at early or mid or even late R6 than it is once you get into R7. I'm not going to say out of the woods with it, but the damage has already been done at that point. So you have an opportunity more for revenge than for control once we get into R7, once we get into a mature pod color with these insects. Now, in terms of control, the good news is in Illinois, we have a variety of materials that are pretty effective for us. You might see some material or recommendations out of the southern United States where they have some issues with resistance on this insect. They also have perhaps more issues with defoliation from those earlier generations in the southern United States. We don't see as much of that, and we're not seeing resistance necessarily in Illinois, which is a good thing. We get pretty doggone effective control with most of the pyrethroids that we use most frequently. And this is from a study that I did actually this past fall, where we saw pretty effective control against a pretty large population of Japanese beetles there on our research farm. One thing I do want to point out here, you do have to consider the pre-harvest interval of these insecticides. It's pretty easy. Some of these are fairly long. You see up to maybe 30 days with some of these effective insecticides. It's not hard to imagine that pre-harvest interval becoming a problem when we talk about late season management of these insects. So keep those in mind. What I would argue is if you're getting to within 18 days, for instance, probably you were close enough to harvest at that point, if that's going to be a problem, that the damage has already been done in most cases. But keep these pre-harvest intervals in mind. In the case of our particular trial, we sprayed on September 3rd. That was around the stage that I showed you in that previous picture, talking around middle of R6, maybe early R6 on September 3rd. We ended up harvesting that field October 14th, so we were fine in terms of our pre-harvest interval. It didn't pose a problem to us in that particular field. But something to keep in mind if you do have to put out an insecticide for pod scarring with bean leaf beetles, pay attention to those pre-harvest intervals and make sure you're not violating that portion of the label. Now that's a fairly good segue into some work that I've been doing with ISA last year and going on into this year, hopefully on into the next couple of years, looking at the effective residual control that we get from insecticides. And this is based on really a question I get from farmers and from consultants just about every year. Usually comes up at the end of the season, usually comes up either with bean leaf beetles or stink bugs. And it's, I sprayed an insecticide, but I still got bean leaf beetles at the end of the year. I still got stink bugs at the end of the year. Did I use the wrong material? And the answer, typically, it's not so much that we used the wrong material. It's that we used it at the wrong time. And what we want to do with this project is really get a better understanding of, if I use an insecticide, how much control am I going to get out of that? How long is it going to last? And we're used to, in a lot of cases, maybe some longer periods of residual control that we see from certain herbicides, that we see from fungicides. In many cases with insecticides, we might not be looking at as long of a period of effective residual control. So the way that we're doing this, we're actually doing it in concert with the normal insecticide trials that we typically do. In fact, that trial I showed you earlier from bean leaf beetle, we also performed this analysis on that same trial. So we'll go out and we'll spray our small plots. Our plots for this tend to be 10 feet wide by 40 or 50 feet long, which is long enough that we can go through with a sweep net and sample those insects. And then what we're going to do is collect soybean foliage from those plots that we've just sprayed, and we'll collect that foliage repeatedly. So we'll collect it a day after application, we'll collect it 3 days after, 10 days after, 14 days after. If we're seeing control still at 14 days, we'll continue collecting that foliage. We put it in these little petri dishes. As you can see here, they have an agar media in them that prevents those leaves from wilting. And then we're going to expose them to different insect pests. In this case, we did bean leaf beetles. Bean leaf beetles, because they're small, because they love to feed on soybean foliage, they do really, really well in this assay. We've been able to get some good data on bean leaf beetle from this. And you can see here in this case, I have a leaf that was untreated, and you can kind of see what they did to this. And the treated leaf over here, you can see not a whole lot of feeling, and I don't know how well you can see those beetles, but they're not doing so hot. And that's ultimately the measurement we're looking at here, is when we expose these beetles to that foliage, do they live or do they die? We don't do that by checking their pulse. They're a little too small to check their pulse. The method we use to evaluate that, it's pretty technical. We take a little stick and we poke them, and if they respond to that, they're alive, and if they don't respond to that, they're dead. So that's the kind of highly technical science that we're doing here in my program, counting dead beetles. But by looking at this measurement, we're able to go through and determine how long are we getting effective control from these insecticides. You see here another, maybe a little better picture of that 1 day post-application. We've got a little bit of feed in here, but more importantly, we've got 1, 2, 3, 4, 5 live beetles. Over here, these beetles aren't doing so hot. They were not able to survive that material. And if you look at the kind of data that we see over, this is from that same test that I showed you earlier. Initially, we're going to get very high control, up around 30 to 60% mortality when we expose those beetles. One thing you'll note, they are able to avoid that if they can taste that foliage and they can detect there's an insecticide on it, so we don't get perfect mortality. But you'll see that mortality starts to drop off fairly quickly. And within 14 days, we're getting very low rates with most of our materials, although we have a couple that are still hanging on pretty well. Now, ultimately, what we want to do here is collect this information on a variety of insect species. You can see here we're doing it on Japanese beetles as well. We're hoping to be able to test this against green cloverworm, hopefully against stink bugs if they can perform in our assays. And we also want to do this over a variety of trials. So we did 4 different experiments last year. We'll conduct 4 additional experiments in 2021. Overall, our goal with this is to develop sort of a database and see how long these materials last under different scenarios and make this information available through a web-based database, so that when you're considering an insecticide application, you'll be able to go into that and see, okay, based on kind of the environmental conditions I'm looking at, based on the insect pest that I'm targeting, how much control am I likely to get from this? And with that information, we're able to hopefully time our insecticide applications a little bit better and understand, in a situation where we had to put an insecticide out earlier, how long that material is going to give us some effective control. In the meantime, what I would recommend to you, with most of the insect pests that we're looking at, and especially if we talk about stink bugs or bean leaf beetles later on in the season, if it's been longer than 7 to 10 days, don't assume that you're getting a whole lot of control from that material after that point. Unfortunately, insects come at us at different times, right? And that's one of the many reasons why monitoring and spraying at economic thresholds is so critical to getting effective control. We want to make sure they're there when we spray that material, and so that if we have to spray an insecticide, that we get what we're hoping for out of that material in terms of insect control and ultimately in terms of protecting our yield. With that, I really do appreciate your time here this morning, and I'll be happy to open it up to any questions that we've received throughout the talk. And certainly don't hesitate to reach out to me, email, Twitter, phone, whatever it might be, if you have any questions now or on into the season.
Nick, thanks for some really great insight there. Folks, for out in the audience, if you have questions at this time, you're able to use the ask questions along your left-hand side of the screen. Go to that tool and submit any questions you have, and we'll get them to Nick. But Nick, while we're waiting on those questions to come in, we do have some that was pre-submitted, and I'll just kind of go through those as we wait for the other one. So, based off the amount of population that we seen last year with the bean leaf beetle in those particular counties within East Central Illinois, whether they were treated, non-treated, what likelihood will those counties have issues next year? Especially, they're not going to go beans on beans, but it would be in a rotation, migration of that next generation. So what kind of risk are those growers at?
Yeah, that's a really good question. And one thing to remember with that question is we do have 2 generations per year, where it wouldn't surprise me, and especially if this winter weather calms down for us here. Bean leaf beetle, like I mentioned in the talk, it's one of those few insects where a pretty harsh winter actually does have a measurable effect on bean leaf beetle survival. Where we might see some higher populations, especially, would be in that overwintered generation. So in the spring, when they first come out of those overwintering sites. Now, of course, if you have a high population then potentially you have a high egg lay that could translate over to the subsequent generations. However, with each generation of these, we see a lot of mortality in the soil that's based on soil conditions, it's based on natural enemies, it's based on, in bean leaf beetle, on a lot of factors that maybe surprisingly we don't understand that well. It's amazing how hard it is to measure what's going on below ground with some of these below ground insects. But the good news about it having 2 generations is we'll probably have a bit of a heads up with that first generation. So we may see next July a heavy flush of these, and typically that July flush isn't enough to really make any difference to us in terms of yield. But if we see that, that's a really good indication that we need to be watching for that next flush that occurs on into August. But in terms of knowing what's going to happen in late August and September now, based on last year, they've got several opportunities to die between now and then. And hopefully they take us up on some of those opportunities, and we get some attrition from the winter, from soil conditions early in the summer and late in the summer on that other generation. So it's hard to make a real strong prediction on what's going to happen next year. And that's kind of the reason that we see these outbreaks sort of sporadically. Sort of every few years we see that higher population. And it's always a bit of a surprise to us. It's because I think those soil conditions in particular play a big role on how much survival we see.
No, great insight, Nick. As we talk about survival of the overwintering bean leaf beetle, what would be some conditions that would favor a high mortality?
Yeah, conditions that would favor high mortality over winter, probably the worst case scenario for them would be if we had a lot of rain, which some areas had that, and then we had soils get saturated, leaf litter get saturated, and then we have some heavy freezes without snow cover. So right now, the very low temperatures in and of themselves, they're going to have an impact for sure on bean leaf beetle. And again, my colleagues at Iowa State have developed kind of a model based on local weather conditions to predict overwintering survival. Again, with the goal primarily of determining how big that initial flush is going to be. But don't underestimate the impact that moisture has as well, and especially moisture in those overwintering sites. So insects in overwintering in general, they tend to do pretty well if they're able to maintain shelter, and they're able to stay dry in those conditions. And snow actually helps them, right? Getting some snow cover, just like it does for the wheat, helps them to overcome that. What they don't do terribly well in is if they get frozen. If you end up with an insect in an ice cube, from a lot of moisture that's out there, they do pretty poorly in that scenario. So depending on where you're at in Illinois, that might be exactly the situation that you've seen, is some wet conditions followed by a heavy freeze. But of course, they continue to surprise us, and sometimes they do a lot better maybe than we expect them to.
No, understandable. As it relates to that generation that's going to overwinter feeding on the seedlings, a lot of folks are looking at seed treatments, adding the insecticide with it. By having that insecticide there, how much does that, I guess, link to reducing that next generation that's going to cause an issue during potting? Is there a direct correlation to that, or a lot of those pests that are the populations that cause issues that R5, R6, are they migrating in from a different area, or would they have come from that field?
That's a really good question, and there's a few layers to that. One, with the seed treatments, you do get control of those seedling bean leaf beetles. Usually doesn't translate to much in terms of yield from control of that generation, but it is effective on them. With the bean leaf beetles that come in later, you actually have a combination of migration and locally produced bean leaf beetles. So they're kind of like me. They're not going to run any farther for a hamburger than they have to. So if there's a meal right there where they emerged, that's where they're going to stay. If there's not, if they emerge in a field and it's kind of on its way out, they're going to move on over. And what we see really, where we see those flushes at the end of the season, often it's you have bean leaf beetles in a field. that field matures and there's a green field next to it. So they sort of piece out of that maturing field and move over to that other field. Well, as those fields start to senesce, they get more and more concentrated in the fewer fields that are left. And so you do see a lot of an impact in those fields from the surrounding area. So I don't know if anyone's actually looked explicitly at the connection between early season control and what we see late in the season. Based on my instinct, just based on what I know about this insect and how it moves, I would guess that link would be pretty weak. I would guess you'd have a hard time seeing an impact from early season control on late season populations. But of course, that's just a guess because I haven't seen a study on it, and well, it would be a really difficult study to do. It would be an interesting study, but they're pretty squirrely little insects. They do move around on us quite a bit, and tracking their movement behavior even can be fairly difficult.
Understandable. As we look at the different type of insects that are feeding on beans and pods during the times we were just referencing, at the same time, there's stink bugs out there. And it was asked, kind of describe the difference between how the bean leaf beetle will attack the bean plant pods versus the stink bug.
Yeah, that's an excellent question. And there's a reason. So our thresholds on stink bugs are much more aggressive than our thresholds on bean leaf beetle. Threshold on stink bugs like 9 per 25 sweeps if you're going out with a sweep net, 1 per row foot. Threshold with bean leaf beetle, we base it more on pod feeding, but if we're seeing 10% of pods fed on, we're seeing loads and loads and loads of bean leaf beetles out there. The reason is that bean leaf beetle is feeding specifically on the pod, on that lining of the pod. And you think about, that green tissue, very similar to leaf tissue in terms of what it's made up of. That's really the food source that those bean leaf beetles are going for. And so it's the reduction in quality when you open that pod up and allow moisture in. That's how they're damaging the seed. With stink bugs, they're actually feeding right through that pod. They don't care about the pod itself so much. And they're feeding on that seed inside of the plant. So you get a few things with stink bug feeding. One, you get that entryway into the pod from that hole they put into the pod. So you get an opportunity for the exact same sort of damage that you did with bean leaf beetle with pathogens and moisture, maybe less of it because it's a smaller opening. However, then you also get feeding directly on that seed. And so when they feed on that seed, it actually kills a little portion of that seed. The rest of the seed grows around it. And you get this sort of distorted shape. We call it cat facing in if they do the same thing on an apple because that tissue sort of grows around it. In soybeans, you get this kind of shriveling, this wrinkling of that seed. And then you get darkening. You get, of course, the pathogens, the same ear rots and that kind of thing. So with stink bug, it's like you're getting all the damage of bean leaf beetle, but then some. And that shriveling and that shrinking of the seed and that reduction in quality that way is really more severe than what we see with bean leaf beetle. And that's why we're more aggressive on stink bugs if we have a stink bug problem than we are with bean leaf beetles.
Thanks, Nick. Based off our time, that's really all we have for Q&A. At this time, we do have the image below that shows the QR code for CCAs to obtain a CEU in pest management. Use your app to take a picture of that. If you do not, the email address is also below that you can send your CCA number and the information that you attended this breakout session. So with that, I would like to thank Nick for his presentation today and thank you all for attending today's breakout session. Don't forget to tune in next week on Wednesday, February 24th, beginning at 9 o'clock for the next round of educations for Summit. Thank you.